So, good evening, everyone. Today is the uh, third lecture or fourth lecture of our NPTEL course Algebra-I, and this week's contents are Silo theorem and free groups. But we'll be mainly focusing on Silo theorems today, as we discussed in the last class. And since professors will be continuing lectures uh, for free groups for week 5, so we can do that in the next class. So let's wait for 2 or 3 minutes for everyone to join, and then we can start. দেব, তুই রেগে আছিস না? ঠিক আছে। So we are waiting for people to join. So it's already 6:02, 6:03. So I think we should start. So this is our lecture 4, and today we will be focusing on Silo's theorem. So let's recall what is a Silo's theorem, and yeah. So theorem. Let G be a group of order p to the power alpha n, where p is a prime not dividing n. So the first Silo's theorem says that Silo p subgroups of G exist. That is, this means what? That subgroups of order P alpha. The second Sylot's theorem says that if P is a Silo P subgroup of G and Q is any P subgroup of G, then there exists G belongs to G such that Q is contained in G P G inverse that is Q is contained in some conjugate of P. But note that P and Q have same cardinality, that means that both have order P to the power alpha, and GP G inverse, I mean this conjugation operation is an automorphism, right? So GP G inverse has the same order as P because image of P under this conjugation is GP G inverse. So Q is contained in this and Q has order P to the power alpha. So by Pigeonhole principle, GP G inverse should be equal to Q. So in particular, any two Silo P subgroups are conjugate in G. Now for the third Silo theorem, which tells us about the number of Silo P subgroups in a group, the number NP of Silo P subgroups of G satisfies NP congruent to 1 mod P. That means P divides NP minus 1, or similarly NP minus 1 equals to the power alpha, where R belongs to some natural number. Okay. Further, NP is the index G dot NGP GP of the normalizer of any Silo P subgroup P, hence NP divides N. So what is NGP? NGP is the elements of G prime, such that G prime P, G prime inverse belongs to P, or you can say equals to P. Both are similar statement. So now as okay, so let's start with our first theorem. First question, that is question 1. Prove that if order of G equals to 312, that is 2 cube dot 3 into 30, then G is not simple. So what is a simple group? Definition: G is simple if it has no normal subgroups except itself, that is G, and the identity. So yeah, so what do you have to do for question 1? What do you have to show? That is it has a normal subgroup, and one way to show is that that the Silo P subgroup is unique, or the number of Silo P subgroups is 1. Why? Because why then it would imply that it is normal, because you know that all the Silo P subgroups are conjugate to each other. So if the Silo P subgroup is normal, suppose it is say n, then G and G inverse should be n for all G of G, right? So that's why showing that Silo P subgroup is 1, number of Silo P subgroup is 1, equivalent to showing that G is not simple. Not equivalent, one way to show that G is not simple. So can you try for 1 to 2 minutes?
So here we will use Silo's third theorem.
Yeah, Silo's third theorem.
And for one of the either for 2 or for 3 or 13, we will show there is only unique there is a unique subgroup,
Yeah,
and that will be normal.
yeah. So showing the Silo P subgroup is unique, that is np equals to 1. In this case, n13
For
equals
n
to
is
1.
to 13.
Is enough.
Yeah, yes. So
Hmm.
So in my MSc, I
Yeah.
have done I have done this like 1 plus 13k
Yeah.
uh, divides the remaining one part of 3 112, that is 24,
Hmm.
and we will find that values of k.
Hmm.
And here 1 plus 13k divides 24.
Hmm.
Here k is 0 only.
Hmm.
So 1 plus 13 into 0, that is 1.
Hmm.
So there will be only one subgroup.
Yeah. Yeah. So
I have done like that.
yeah, yeah, yeah. Actually, okay, I will be formally writing the proof. So before that, yeah, you should like do this way that 1 plus 13
13.
dot
Yeah.
k should divide to cube dot
Yeah,
3.
yes, sir.
Yeah. So it is what it is 24. So you see that putting k equals to 0 gives you a solution.
Yes, sir.
So but when you put k equals to 1, that is 24. 24 does not divide, sorry,
14.
14, yeah, does not divide 24.
Yeah, yeah.
And k equals to 2 already exceeds 24, so
Yes, sir.
nothing to talk about. Yeah. So in this way you will see that your np uh,
Is equal to 1 plus 13k.
yeah, so should be 1. So we should write this formally. So I have to write it because the notes will be available on the website, so for that purpose. uh, okay, so solution, uh, huh, the number of uh, the number n13 of silo 13 subgroups of G satisfies uh, n13 congruent to 1 mod 13, and n13 should divide 2 cube dot 3. So for the second part, why we are doing this, because it was not mentioned in the 3 of the Silos theorem that we given. So it is we are doing this because Silo with uh, so from here you will see that this thing. So your aim was p alpha to the power n. So n you can write this as this: m and p has their GCD equals to 1. So from here you can, combining these facts, you can see that this. But you see that now this implies 1 plus 13k should divide n13. For k equals to 0, 1 divides, what am I writing, 2 cube 3. So for k equals to 0, 1 divides 2 cube 3, that is 24. For k equals to 1, 1 plus 13 is 20, 14 does not divide 24. For k equals to 2, 1 plus 13 dot 2, 27, already exists 24. So only possible value of n13 is 1. That means the silo 13 subgroup is unique. So it is normal by the silo second theorem. So G is not simple. So algebra 1 WhatsApp group is still active. I think it was dissolved, right?
Okay, it was just for fellow learners. Like you can continue. Like I just asked it out. Yeah.
Yeah. Okay. Okay. So now we continue to our second question. Suppose G is a simple group with order of G equals to 168. The question is how many elements of order 7 does G contain. So you can try this for 3-4 minutes. Since you need to think if you are doing this for first time. And let me know if someone can answer. I know you. রেগে আছিস না রে? মন খারাপ হয়ে গেছে? Sure. I deserve this.
Sir, 48.
Yeah, it should be 48. Yeah, it should be 48. So, as it is already given G is simple, So the case of unique silo 7 subgroup is denied.
And so there will be
Yeah,
uh, eight number of seven order subgroups,
yeah,
and there are six elements in each
each of them.
subgroup,
Yeah,
and of order seven, and then will be 8 into 6, 48,
yeah,
something like that.
yeah. So okay, I'll just start writing down the solution. The number n7 of silo 7 subgroups of G satisfies n7 mod 1, n7 congruent to 1 mod 7, and n7 dividing 2 cube dot 3, that is 24. The only two factors of 24 which are 1 mod 7 are 1 and 8, right? Because you can check this, those who are seeing this for the first time, but I hope you are already familiar with these things. So these are the only possible values of n7. Please let me know if you have any doubt or anything. If n7 equals to 1, then there is a unique silo 7 subgroup H which is normal but G is simple. So n7 cannot be 1. The remaining thing so n7 has to be 8. Now cyclic groups of same order subgroups of same order are either equal or disjoint, right? Because if they have a non-trivial element together, then you can just since it is cyclic, so you can just repeatedly take powers of it, and you will get another subgroup like in the primary one, uh, which will imply that they both are equal. So now every cyclic group of prime order P has P minus 1 generators. Not order, you can just yeah so the total number of elements of order 7 is uh, 6 into 8, that is 48. Okay, uh, let's go to our third question, question number 3. Prove that if
Sir,
yeah
so in the last question, where we have written cyclic subgroups of same order are either equal or disjoint.
cyclic subgroups of same order, of same prime order, I should write it. Yeah,
I'm asking that how we get that that these eight, these six, or not six, these eight subgroups are disjoint. How can we say that these?
oh, because the n7 you are getting, these count the distinct Scylopy subgroups, right?
So they can be element in these groups
I mean,
that that can be seen, no?
then then there is no point of counting it, right? Because if you are counting the same subgroups two times, you can count it same subgroups like infinite times, right?
And then they will be disjoint by the
Yeah, yeah,
result written
yeah.
down there.
N7 is the count of distinct Scylopy subgroups. They can be
Okay,
conjugate, but they cannot be equal, right?
okay, okay.
Yeah, I mean, you think that if it is uh, like you are counting same subgroup twice, then you see that
No, actually, I'm thinking there can be one or two elements
oh yeah, yeah, that
that will be same in two groups or two
yeah,
subgroups
already identity is there, so they are not
other
any
than identity.
yeah, other than yeah, that is the point, that if, okay, suppose say h1 is our first one and h2 is our second one, and suppose say h is a non-trivial element containing both of these,
Yeah.
then you just multiply, take orders up to h uh, 6, yeah, 6. So this will be uh, here, and this will be here too, right? But the
Yes.
cardinality is already 6, and
Then the whole group will be same.
yeah, and h7 has
They have one
order
no
7,
identity element common.
so these cannot be identity, so these are all
Yes, yes, sir.
yeah, yeah,
Okay, I
okay.
got it.
Okay, so the questions I have, uh, I think it is little monotonous, but okay, we'll be uh, this will be our last same type question. Then G is not simple. This is to just but this is not that, I mean, okay, let's see how many of you can get it, then you can change the question pattern. Okay, this will not be entirely easy. So let's try this.
Sir, if we try to find out 7 silo subgroups and 2 silo subgroups here,
Hmm.
so I'm getting that there will be eight 7 silo subgroups and
Hmm.
7 2 silo subgroups.
Hmm.
This is the only pair that will work here. If we take another possible values,
Yeah.
that will not work there. It will not complete the number of elements.
Can you tell me again last part what you just said?
So I said if we take another possible values like for 7 silo subgroups, there are two values,
Hmm. Hmm.
either unique or
Hmm.
either eight.
Hmm.
So if we take k is equal to 0 and one 7 silo subgroup, and then find 2 silo subgroups,
Hmm.
using that we will not able to uh, meet the conditions of order of the group, something like that.
Yeah, yeah. The way you have got is right, but the argument should be more precise. Like why silo two subgroups should be normal. That part, can you think? Like the previous one, what we did, can be made. Uh, yeah, can be used here. That how many elements of order 7 are there. If you can find that, then you see that uh, how many elements are left, and by like index theorem there should be a silo p subgroup like Cauchy first theorem.
Yes, sir.
Yeah, so there should be at least one subgroup of order 8, and it should not contain any element of order 7, something like that. This is just the last step what is left.
Okay, sir.
উড়বি না রে ওর পর পর রেগে আছিস কেন? কি দেখছিস এগুলো? তারপর রেগে আছিস কেন? মুখ খুলে আছে কেন আমাদের? না এরকম লাগে। রেগে আছিস? বল না কে? বল না। তুই রেগে আছিস? আমি কি বলে দিয়েছি আমার? Okay, let's try this. So n7 uh, is congruent to 1 mod 7, and n7 divides 2 cube, that is 8. So the possibilities of n7 are only 1 and 8, right? Because you see, I mean, this is trivial to see, right? Now, so there are two cases. If n7 equals to 1, then silo 7 subgroup is normal, like we said in saw in the previous arguments. Then G is not simple. So going to the next argument, that if in n7 equals to 8, so what happens? We already know from previous exercise that there are 48 elements of order 7, right? Now okay, going to the next page. Now let K be a silo 2 subgroup of G, right? So okay, let me show this, that following the first Silo's theorem, that is silo p subgroups of G exist. So there is at least one silo 2 subgroup that I denote by K, and order of K is 8, right? So every element of K has order dividing 8. So now following this, none of the 48 elements of order 7 lie in K. We know order of G is 56, right? So there are already see, we are already covering 56 elements. So 48 plus 8 equals to 56, and all of the elements in all, all the elements in the this were non-trivial. I mean, we did not count identity, and we are already counting identity in k. So now, if k dash is another silo 2 subgroup, then k dash should be g k g inverse for some g of capital G. If k dash intersection k is non-trivial, then there would be an element in k dash not in k whose order is his order divides 8, so does not divide 7. That means what? That but this contradicts the cardinality of G, because already we have covered 56 elements, but if there is another element, this would exceed the cardinality of G. That means, so just k oh I have done a mistake. Should be okay, my just minus, so done is empty, so should be k, that is k is unique silo 2 subgroup, so k is normal, which implies G is not simple. So the trick lies in the case that you have to keep track of the elements, not only like sometimes you have to keep track of the order of elements, just not only the number of subgroups. Okay.
Sir,
Yeah.
you have changed the sign intersection with this minus sign.
Yeah.
What difference did it make?
Yeah. Mm. So the first one was that I was trying to actually my aim is to show that uh, if there is any other element which does not lie in K, and if it has order which divides 8, that is like
But,
yeah.
sir, k dash intersection k not equal to e. This also represents same thing, na?
But the No, 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 no. I can understand what you are saying. That yeah, this would not mean this. Not in K. If
Okay, okay, okay,
yeah.
okay. Now I got.
Hmm. Okay. So okay, let's do this. It is more rigorous, but it would clear some concepts. So why not? Okay. Question 5. Uh, prove that if mod of g equals to 231 is 3.7 dot 11, then uh, the centralizer of g, uh, center of g, I think, yeah, center of g has order greater than equals to 11. So from here one can show that g is not simple. It's okay if it seems little abstract, but yeah, let's try this. You are angry? No. It's not.
এখনো তো শেষ হয়নি তো। ঝাঁঝাল আছে, এখনো হয়নি। Dance, baby, dance. আহা, কেন যে হয়? না, ভুড়িটি দেখে কি করলা তুমি?
So your voice is not clear. Can you please check?
That is silo 11 subgroup. Let K uh, is unique so normal and G is not simple. So now we claim that this K belongs to center of G, not belongs to. K is a subgroup of center of G. Center of G is nothing but the elements G prime of G such that G prime dot G equals to G dot G prime for all G belongs to G. Okay, we claim this, right? This is not true yet. Now we will prove this by contradiction. We will prove this by contradiction. Let for some G belongs to G and small h belongs to K, say hg not equals to gh. This implies h not equals to gh g inverse, right? But gh g inverse belongs to K because K is normal, because K is normal, that means G K G inverse belongs to, is a subgroup of K. Now order of K is 11, that is prime, so K is cyclic, right? And this implies GH G inverse equals to h to the power n for some m belongs to 2 to 10. Can you tell me why this is happening? Because h belongs to k and k has order prime, so every non-trivial element of k is a generator of k, right? We have used this in earlier of our one of our problems. So uh, this implies this, right? Because this belongs to k, so it is a power of h. And yeah, applying the conjugation by g operation repeatedly and noting that g change g inverse equals to g inverse of n, right? And this would imply that h to the power m of n, and this implies h to the power n, and it follows that gk is g to minus k is to the power m to the power k for any natural number k, right? Can anyone tell me how this is happening? Okay, I should write down a little bit. It should be g dot dot g h g inverse dot 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 g inverse. This would imply g d h m g inverse dot dot g inverse. These are like k minus 1 times, these are k minus 1 times, and following this you can it should be m. Again, if you do this continuously, you will get this, right? Okay, this should be left like this. So in particular taking k equals to mod g, the order of g in capital G we have, this is small k, h equals to 1 dot h dot 1 g of k h g of minus k, which is nothing but m to the power k, right? Which we have done just now. And since h has order 11 m to the power g mod g, that means your k is to congruent to 1 mod 11. Can you tell me why this is happening? Because see that from here for k minus 1 equals to e. So this implies that order of h should divide this implies that 11 divides m to the power k minus 1, right? Okay, so in other words, k is divisible by the order of m as an element of 11z but this is a group of order 10 and m is not identity. So by Lagrange's theorem, the order of m is uh, uh, is 2, 5 or 10. But none of these, right, none of these can divide order of any element G of capital G, right? Since order of G equals to 3.7.11 and there is no 2, 5 or 10 in this multiple, so we have a contradiction. So contradiction to what? Contradiction to this fact that suppose there is a element in capital K such that this inequality happens, but if we contradict this, then this means that for every element of G and for this small h we have this equality. That means what? That the capital K belongs to center of G, right? So we have that capital K belongs to center of G, and this implies that and this is nothing but 11. So we are done. Okay, this was little rigorous, so please tell me if you haven't been able to follow this. If you followed, very good, but if you still have doubt, you can ask me, and if not, then you can again look in the lecture note, and I have tried to write this down thoroughly, so I hope it will be clear.
Sir,
Yeah.
sir, here in other words, the line next to it. So here.
Yeah.
So what will do in the end? Z by 11Z.
Yeah, that means the cyclic group of order 11.
And what we have written in the power?
So this is from Fermat's little theorem.
No, sir. I'm not asking that.
Oh yeah,
In the next line, Z mod 11Z.
yeah.
What you have written there? That line. Can you please tell that?
So you
In
know,
other words,
was
K is
k is
divisible by
divisible by the order of m as an element of z by 11z star.
so Z by 11Z star meaning.
This means that I should, sorry, I should have zero. That means all the
Okay, okay, okay.
non-zero elements. Yeah.
So it is this is group under addition.
I think as it is a cyclic group, so
Under
yeah,
addition
this
modulo
is a group.
11.
Yeah, this is a group under addition. Yeah,
Modulo 11.
yeah.
Okay.
Okay. I think uh, okay. Let's move on to some other type of problems because these are getting monotonous. But all the silo theorem, silo related problems are like these only. Like there are some uh, okay, let's do this. There are some other type of problems also. So this was problem question 5. So question 6. Show that a normalizer of P equals to normalizer of P for any silo P subgroup capital P of G. Okay. Try this for 2-3 minutes, then we can start discussing this.
মাঝখানে এখানে কানেক্ট হয়ে গেছিল দিয়ে তারপর হচ্ছে যে
আচ্ছা তুই রেগে আছিস কেন রে? কি
খাওয়া কেন লেগে আছে
তুই কাঁদছিল?
না এটা আমার শরীরটা খারাপ।
না, দুম করে তো শরীর খারাপ, আমি যখন থেকে বলে দিয়েছি তো শরীর খারাপ হয়ে গেছে।
না আরে আমার শরীরটা খারাপই দুপুরের পর থেকে আমার শরীরটা খারাপই ছিল মাঝখানে এখন চাঙ্গা হয়ে গেছে।
তো এখন চাঙ্গা হতে পারছিস না? আমি জাস্ট ভাবছিলাম যে হ্যাঁ তুই হয়তো যদি বড় হতিস, কারণ আমি ভাবছিলাম যে আবুলের কেন খারাপ লাগলো না, আমার কেন খারাপ লাগছে।
ওইটাকে জাস্টিফাই করার কোনো দরকার
তো
নেই।
সেইটা
ওর
আমি
খারাপ লাগছে দ্যাট ইজ এনাফ।
হ্যাঁ
সেটা তুই জাস্টিফাই করার জন্য পুরো খিচুড়ি বানিয়ে তাতে
খিচুড়ি কোথায়, তোর এখানে কেন খারাপ লাগলো? আমি ভাবছিলাম যে আমার তাহলে বোধহয় ও এরকমই ভাবছে যে আমার থেকে বয়সে বড়, ঠিক আছে সেইটা আমি বলছি। তাহলে তোর কেন খারাপ লাগলো আমি বুঝতে পারলাম না।
তোর বুঝতে হবে না কাজ করবি
বল তুই শুধু
কি কি না বল বল কমপ্লিট কর তাহলে।
আমরা ভালোবাসি বলবি ঠিক আছে। করছিল স্যার স্যার করছিল
না
অভিশাপটা কি এঁকেছি
না না ওটা আমি এখন কিভাবে ছাপ তুলছি
ছাপও তোলা যায় ডেঞ্জার আসবে ঠিক আছে কথা বলিস না ওকে সো okay so I should be clear what is a normalizer of a I think I told this solution normalizer of P should be small g of capital G such that GP G inverse is to P. Now let's try to solve this together. Let small x belongs to NGP, then have that xp x inverse equals to P, right? I mean this implies that equality, so I should be writing this because P is a finite order group and the conjugation by G is automorphism, so order of GP G inverse and P should be same, so hence the equality. Now for any small y belongs to capital NGP, we have xy x inverse belongs to NGP, right? Okay, so small x NGP x inverse equals to NGP, that is small x equals to NG of P. So this was quite simple, but for the other direction to prove the other inclusion, let small g be an element in NG of P. Then we have that G NGP G inverse equals to NGP, and P belongs to NGP. This is trivial because P is a subgroup. So GP G inverse belongs to NGP, right? So GP G inverse is a silo P subgroup of NGP. This is because P is already a silo P subgroup of G, so P has the maximal order of P power. So GP G inverse is also silo P subgroup. So it is a silo P subgroup of G. So it is a silo P subgroup of NGP because it is contained in NGP also. But P being normal in NGP, this is a theorem. So can just keep that exercise. This is not hard. Uh, this is actually two-liner exercise. So is the only silo P subgroup of NGP. This implies that GP G inverse equals to P, that is small g to Ng of P, right? So I think the symmetry group will be done in next 2 or 3 classes. So better to leave it for now.
Excuse me, sir.
Yeah.
Sir, can you please tell us how to prepare for the exam?
Like
For this.
for this
Uh,
course,
yeah, yeah, yeah.
of course, actually
Now,
haven't.
what should we do? How should we prepare?
Mm, I actually haven't given exam for an NPTEL course. Uh,
Sir, are you a PhD scholar or
yeah, yeah. So
sir, in
my
which university?
it's in IIT Madras.
Okay, okay. Sir,
So
you are doing PhD in?
so my topic is algebraic geometry. So it's little algebra and topology and combinatorics. Those. So you guys are masters, like you have completed BSc and
Yes, sir, I have just completed my master's
oh, okay, okay.
3 months ago.
Uh,
And now I am preparing for CSI and NET.
okay,
Uh,
okay.
so I'm just doing this course side by side.
Uh, so oh yeah, it will be beneficial if you complete the course since you are yeah attending. So there will be a certificate, I guess.
Yes, sir, if you give exam and you score that minimum criteria, then you can get a certificate.
Uh, so the assignments you are doing,
Yeah.
the questions are
There are
hard.
MCQs there.
So
Only MCQs.
only MCQs.
Yeah.
Oh, then it is not much of use.
Yes, actually.
Uh,
At only 15, I think 15 to 16 MCQs in each assignment of each week.
okay, so try to understand the like how you are solving those problems. Like try to explicitly understand those. Maybe questions are given from there, but since you are
Actually, some questions are already done in my MSc. Actually, I have
uh,
completed my masters in Punjab University,
uh,
Chandigarh.
okay, I actually did class you know actually taught some I was taught by I forgot his name, but he was from
Miss Kurana, sir.
no, yeah, at that time he was an academy. He wears glasses and he was very good. Like he did his masters from there, like 15, 16, 2015, 16.
Okay, okay.
Okay.
Actually, sir, our teachers were also good there. Actually, in north side,
Uh-huh.
India, Punjab University is majorly for algebra, modern algebra.
Yeah, yeah. There is a guy in combinatorics also. He's very good.
So even we had a teacher uh, which is linked to NBHM also.
Okay, okay.
The NBHM exam in north side is majorly conducted in our university.
Okay,
We
okay.
have a library also named after NBHM.
Okay, okay, okay. So north side NBHM headquarter is there.
Yes, sir.
Yeah.
So, sir, I actually joined this course just for the certificate. Like, I am preparing for the exam. It will just add in my resume or something like that. If I want to apply for PhD further.
Yeah, yeah, yeah. Also, it will be good because the theorems you are getting revised in your head. And
Yes, sir. Actually, in exams, yes, and it will be objective paper, na? It's not the subjective. So we are just preparing for the tricks only. And if I will prepare only tricks, I will forget these theorems after some time.
so that will be bad because after you are getting your PhD admission, you will again have to do these courses. So it's better.
So you have got admission through CS and it
Yeah, yeah.
score.
I got admission through a net exam, but there are several like gateways. You can try Gate,
So,
NBHM.
yes, yes.
Okay, so yeah, keep studying. It will be enough. I think exam. Keep giving exams and okay. Let's focus.
Okay, sir.
I think we can do another problem. Uh, Okay, so let's do another problem and uh, we'll then finish this. Huh? So, question 7. Obtain a Shiloh P subgroup of S4 for each prime P dividing order of S4. So you have to for each given prime that divides order of S4, and order of S4 should be what? That should be factorial 4, that is 24. So yeah, so what are the primes that divides 24? Should be 2, 3, only 2 and 3, right? Because solution 24, 2 cube, 3. So S4 has a silo 3 subgroup of order 3, right? Because it's already 3 there, and only n3 is 2 cube, and n3 mod 3. So all the possibilities are 1 and 4, right? So S4 has a silo 3 subgroup of order 3. For instance, it has E 1, 2, 3 and 1, 3, 2. So there are another also, like you can take 1, 3, 4 or like 2, 3, 4, or like those, and you generate them and you get a subgroup of order 3. It has a silo 2 subgroup of order 8. For instance, you can just take 3 of the defined cycles and generate them, like E 1, 2, 3, 4, and again 1, 2, 3, 4. This is a 4 cycle. 1, 3, 2, 4, 1, 4, 2, 3, 1, 3, 2, 4, and 1, 4, 2, 3. Yeah. So only 2 primes are there. So symmetry groups are in the syllabus of CSIR, NET, and NBHM and GATE. So
Yes, sir.
yeah, and in the next week I think they will be teaching generators and relations for the symmetry groups, right?
Yes, sir.
So you can just in the group also, I mean in the WhatsApp group, yes, you can just solve some problems also there, and I do not get much time during time, but so some Sandeep was there, right? Sandeep.
So now he is not there.
Yeah, okay.
He left the group.
Okay, yeah, you guys can discuss there, and okay. There are still time, I think I have exhausted the problems. Okay, let's finish this class. Then in next week we will be doing programs related to both symmetric group and Silas theorem. Okay.
Okay, sir.
Okay. Okay. Good night. Yeah.